Excuse me. All right, in this video I want to talk about vaccination. So we're talking about practical applications of immunology, and there really isn't a more practical application than this. So let's start by talking about what a vaccine is. So here is the definition of a vaccine. It's actually kind of changing because they're now making DNA vaccines and these subunit vaccines and that kind of stuff. But so the new definition of a vaccine is a suspension of organisms or fractions of organisms that is used to induce immunity. So basically what happens is that you expose your body to either a killed or weakened or live organism, or now just these subunit vaccines where you're exposing them to fractions of organisms, and your body creates both antibodies and then long-term memory cells, memory T cells and memory B cells. So basically, the first time you really are exposed to something is the second time your immune system has seen it. So what it does is it bypasses the primary immune response, which is slow and weak. It takes up to 2 weeks, and you get the wrong kind of antibodies early, and just as a disaster, which is why the first time we're exposed to something, you usually get sick. So the first time you really see something is the second time your immune system has seen it, so that you get an intense secondary immune response on your first real exposure. All right. As far as the history of vaccines, we've talked about how they were vaccinating with the. They realized that milkmaids. Edward Jenner realized this, that milkmaids who recovered from cowpox didn't get smallpox and they didn't die. So that's kind of where the vaccination came from. Prior to that, the Chinese were doing something. They had kids like inhale dried smallpox scabs and stuff like that. But so the vaccination program was really good because variolation, which was being done, actually in inoculating smallpox into the skin, back before Jenner, did have a 1% mortality rate. But at that time, smallpox had like a 35 to 50% mortality rate and killed at least 1 billion human beings. That's where the vaccination programs came from. Here we see just a more common vaccination schedule today, so I want to talk about this a little bit. I also want to make sure this is all still accurate because it's a little bit dated information, so I'm checking with the CDC as well. So first one I want to talk about is the DTaP you see here. You see there the CDC recommends 4 doses of the diphtheria, tetanus, and pertussis vaccine. So you actually see it on here 5 times, but I'm assuming these are things recommended by age 2. So this one over here doesn't count. So you see 4 doses of the diphtheria, tetanus, and pertussis vaccine. We'll talk about the type of vaccine in a little bit. 3 to 4 doses of the Hib vaccine. You see here as well the Haemophilus influenza B vaccine. The 3 or 4 actually depends on the brand of vaccine used, but that's going to help prevent some very serious pneumonia and meningitis and that kind of stuff. Let's see, 4 doses here of the pneumococcal vaccine. So we talked about how 11% of all children under the age of 5 that die from invasive pneumococcal disease. So that's an important vaccine. Let's see, where's polio? We get 3 doses by the age of 2 of the inactivated polio vaccine. Let's see here. I see Hep B on top. There's our Hep A. You need 2 doses of hepatitis A vaccine is what the CDC recommends. 3 doses up top of the hepatitis B vaccine. 1 dose of the MMR, and we'll talk about why some vaccines need multiple doses and others don't. But 1 dose of the measles, mumps, and rubella, or your MMR vaccine. 2 to 3 doses of the rotavirus vaccine. Let's see, is that one even on here? Yeah, right up top. The 2 to 3 doses actually depends on the brand used again. 1 dose of the varicella vaccine, which is the chickenpox vaccine, and hopefully will protect you from shingles as well. And then 1 or 2 annual doses of the flu vaccine is what they recommend, which you see it when you see on here, so yearly. And then there is some question about that one especially, and I'm not so sold on it, to be honest. And I've seen a lot of objective information. You can go to the Cochrane collaboration or just talk to me about it. I can give you a stack of 50 pages to read through about how there's not enough data to know whether the flu vaccine works, and for young children there definitely are some risks associated with it. All right, so that's just the normal vaccination schedule. Now let's go ahead and take a look at some of the actual vaccines. So here we see the main vaccines used to prevent bacterial diseases. So we're going to talk about both bacterial and viral diseases. Certainly, viral vaccines they do last longer and are more effective. So you don't need them as often and that kind of stuff. And luckily, we do have more viral vaccines as you look here. The reason that's a good thing is because with bacteria, we still have antibiotics. I mean, they're not perfect, but they still are helpful. So it's actually a good thing that we have more viral vaccines. So because viruses are harder to treat once you get them. So getting a bacterial disease is probably usually not going to be as dangerous, because at least you have a fighting chance to treat it. With bacterial diseases, it's a little bit different. All right, let's go ahead and look at some of the different vaccines here. So first we see the tetanus, diphtheria, and pertussis. The DTaP used to be called the DPT, but they've changed it a little bit. The D is a purified diphtheria toxoid. So a toxoid is going to be a vaccine against a toxin, not against an agent. So it's actually, the vaccine is not killing Corynebacterium diphtheria. It's inactivating the toxin that it would release. The P is going to be an acellular fragments of Bordetella pertussis, which is the bacteria that causes pertussis or whooping cough. So that means you're no risk of getting it because it's not actually the agent. And then the tetanus again is the tetanus. So it's a purified tetanus toxoid. So both the D, diphtheria, and T for tetanus are toxoids, and toxoids do need a booster every 10 years. So toxoids are just they're a vaccine that inactivates toxins. It targets the toxins instead of the actual microbes. So those are the two big ones, and you do need a series of injections early with toxoids, plus booster shots every 10 years down the road. All right, so that's the DTaP vaccine. Next we have meningococcal meningitis. This is going to be what's called a purified polysaccharide vaccine from the causative agent Neisseria meningitidis, which can cause meningitis. This would be the type B form. Not the only one that causes meningitis, but now that we have this vaccine, this is especially important for college freshmen living in dorms. So they strongly recommend you get the meningitis vaccines. That's also why, though, because this vaccine is working, you're starting to see that the Streptococcus pneumonia is becoming the most common cause of meningitis now. All right, so that's the meningococcal meningitis vaccine. Let's see. Let's go. Next, we have well, let's just go in order here. The pneumococcal pneumonia vaccine is also a purified polysaccharide vaccine. And but one thing you'll see on here, the purified polysaccharide form is going to be a mixture of different strains of Streptococcus pneumonia. So that's going to be pretty helpful. Now, one thing you don't see on here is that there are conjugate vaccines, so like the conjugate vaccine, so like a pneumococcal conjugate vaccine, that's going to be better for kids. It appears that conjugate vaccines work better for children. All right, I'm trying to think, the Haemophilus influenza one would be the same thing, so be a conjugate vaccine. So basically what conjugate vaccines do is they make it so children that have a really weird, poor immune response to vaccines because of the capsule. So the problem is, so when you use these conjugate vaccines, it does make it better for kids, and they can use them you can use them earlier. So most of these polysaccharide vaccines don't work until kids get almost 2 years of age. So when you combine the polysaccharide part with proteins, then it's going to be a much better vaccine. That's why some kids can get vaccines at a couple months now that normally they couldn't have. So that's what the term conjugate means. Just thinks they add a protein to the vaccine, and also it makes it more effective for kids. Let's see. So now we're still talking about the Haemophilus influenza type B meningitis vaccine. We already covered the meningococcal meningitis vaccine. So now we have two meningitis vaccines, which is again why this guy is taken over as the primary cause of meningitis. Okay, those are the principal bacterial vaccines. Let's go ahead and look at the viral ones now. There are more of these, and that's because you don't want to get these diseases. They're much harder to treat. So influenza we'll kind of separate, and we can talk about separately. But I mean, if you're at risk, people that I recommend the influenza vaccine for the most would be people that are at risk for those secondary bacterial infections, because the flu virus can wipe out your immunity, and then you can die from pneumonia or septicemia, that kind of stuff. So there certainly are people that the influenza vaccine, there might be some reward there. But let's skip that for now. See the next ones: measles, mumps, and rubella. Those are all attenuated viruses. What the term attenuated means is going to be weakened. So you're going to have different types of vaccines. You can have an attenuated whole agent vaccine. Those are living organisms, but they've been weakened. So they're obviously the advantage here is they more closely minimize or mimic an actual infection. So they're up to 95% effective. There's no 100% effective vaccine, but the attenuated virus vaccines are the most effective. And usually you don't need a booster, because think about this. the virus is actually alive in you, so you're getting a booster by your own immune system. Your immune system is working for days on this, so you do get kind of an internal booster. So the pros of attenuated virus vaccines is they are more effective and don't need boosters. The con is that could this attenuated vaccine back mutate to become virulent again? Happens all the time, not in vaccines, but you can mutate something and then it can back mutate, no doubt about that. So these kind of vaccines, they're going to induce both cell and humoral immunity, which means both T cells and B cells. So it's a very good form of immunity. It just has that one weakness. And then also, if you're immunocompromised, you definitely shouldn't take this either, because even though it's attenuated, it still is a living vaccine. That's measles, mumps, rubella. Same thing with chickenpox, attenuated virus. Poliomyelitis vaccine and rabies vaccines, those are actually killed viruses. Of course, that term doesn't mean much, but so an inactivated vaccine or a killed vaccine, usually they use something like phenol, which we talked about before, or formalin, which is liquid formaldehyde, to kill them. So these are only going to induce a humoral immunity, though, the memory B cell and antibody response. So that you're going to need a series of injections, usually with an inactivated vaccine like this. Let's see, hepatitis B is going to be antigenic fragments. You're starting to see more and more of those kind of vaccines now, where you're only getting pieces. That way, there's no way you can get sick. You're exposing your immune system to some of the antigens, so you can develop immunity to it. Hep A, another inactivated virus. Smallpox is actually the live vaccinia virus. It used to be obviously the virus that caused cowpox, but now they use this one. Herpes zoster, that's an attenuated or weakened virus that's used only in adults. Then lastly, you have the HPV, like Gardasil, those kind of things. The human papillomavirus is, again, antigenic fractions. So they recommend it for all females in some states, but boys certainly can get it too, because they're the ones that are passing on HPV. All right, let's see. So whenever you see the term antigenic fragment, think subunit vaccines, which we have mentioned before, where you're only getting exposed to little parts of it. So, all right, that's the basics of the vaccines.